In this video, I'm going to show you how to use integration by parts to integrate a function that is the product of a polynomial and a logarithmic function. Now in the previous video, I showed you how to perform the integral using integration by parts of a function that is the product of a polynomial and something else. However, if it's the product of a polynomial and a ln function, it's slightly different. There's a slightly different method to performing that integration. So let's take a look at that now with a couple of examples. So as before, I have my derivatives column and I have my integrals column. The only difference is, or the only differences are, is that one, you have to have the ln function in the derivatives column, and then you put the polynomial in the integral column. So this is the only situation where you put the polynomial in the integral column. Okay, and you only do one row. Okay, so you do one integral and one derivative and one integral. And of course, I'm going to put my minus sign here. Then what I'm going to do is, as in before, I'm going to draw my arrow like so, or make it look a little bit better here. So from the ln to the 2x there, okay, or sorry, the x squared over 2. So what I can do now is I can go ahead and perform my integration, and I'll show you how to do that now. So what we're asked to find is f of x dx, okay, the integral of f of x dx. So ln x dx, which is equal to, as in before, ln x times x squared over 2. So ln x times x squared over 2. In fact, what I'm going to do is I'm going to write it a little bit better here. I'm going to write it this way. X squared over 2 times ln x minus, okay, minus, this is where it's different. It's going to be minus the integral of x squared over 2 times 1 over x. Okay, so minus the integral of x squared over 2 times 1 over x dx. So this seems a little bit counterproductive because we have another integral in here. Well, luckily that is going to be a-okay because of this right here. So what I'm going to do is I'm going to simplify this, and in doing so I get this x squared over 2 ln x minus, okay, so this x cancels with one of these x's, so we're left with x over 2 dx. And then another way I can write this is, I'll have this same thing here, minus 1 over 2 times the integral of x dx. Now, what is the integral of 1 over 2x dx? Well, it's just going to be, we raise the power from 1 to 2 and then we divide by 2. So we're going to get this, x squared over 2 ln x minus 1 over 2, okay, and then this integral here is going to be x squared over 2 plus c. And there you have it. There is our integral. In fact, what we can do is we can even simplify this further and write it like so. So we just combine these 4's here, okay, so minus 1 over 4, okay, I'll write it x squared over 4 plus c. And there is our answer. Okay, that is the integral for this particular problem. So let's look at a slightly more complex problem. Let's take a look down here. Let's scroll down and take a look at this problem. Okay, so how would we solve this problem? Well, we have g at x is equal to x squared ln 3x, and we're asked to find the integral of g at x dx. Again, as in before, we're going to have our table. So we're going to have our derivatives on this side, which include the ln function here, and then we're going to have our integrals on this side here, which involve the polynomial. Okay, so the derivative of ln 3x is 3 over 3x, and in this case the 3's just cancel out, and so we're left with a 1 here. So it'll just be 1 over x. And then the integral of x squared is x to the power of 3 over 3. In a similar manner, we're going to put our minus sign here. We're going to draw our arrow like so, and then we can start the integration. So the integral of x squared ln 3x dx is equal to ln 3x times x cubed over 3. Okay, so x cubed, or sorry, I'm going to get rid of that integral sign there. X cubed over 3 times ln of 3x times ln of 3x. Okay, minus, so this times this, minus the integral of x cubed over 3 times 1 over x. Okay, so x cubed over 3 times 1 over x. So we get, when we multiply those two together, so we get 1 over x times x cubed over 3 dx. Okay, so this x cancels out, this 3 cancels out and becomes a 2, and then we'll simplify this. X cubed ln 3x over 3 minus the integral of x squared over 3 dx. And of course we can take this 1 out of 3 out of the integral here. So we'll do that. Times ln of 3x minus 1 over 3 times the integral of x squared dx. And of course the integral of x squared dx is going to be x cubed over 3. So we will go ahead and do that. So this will come down here. I'll write this here. X cubed over 3 ln 3x minus 1 over 3 times, this integral is going to be x cubed over 3 plus c. And of course we can leave it there, or we can simplify, which I'm going to do here, to our final answer, which would give us x cubed over 3 ln 3x minus x cubed over 9 plus c. And in fact, we could even simplify it even further, but I'm just going to leave it in this form here. And there is our answer. So that is integration by parts for a function that is the product of a polynomial and a logarithmic function. In the next video, I'm going to show you a very cool way to use integration by parts to solve the integral of a function that is the product of a combination of sine, cos, and exponential functions as well, because that's a little bit different, but again, it's also a very good way to integrate those types of functions.